This is in-class exercise 3.8a. We are going to create a berm in this location here to block the view of a person, a 5-foot tall person standing on this platform and seeing a shed that is at an 8-foot tall shed at elevation 94.5. So what this is going to look like in a cross section here, you can see this is the platform with the person standing on it. Elevation is 100.5. They're a 5-foot person, so that puts their eye level at 105.5. And then the building over here, it's a shed that's 8 feet tall. At the bottom of the shed is 94.5, so the top of the shed is 102.5. The difference between this elevation to this elevation, you just subtract 105.5 from, or subtract 102.5 from 105.5, and the difference in elevation is 3 feet. So what we've got to do is build a berm to block the view to this building, and then provide swells at the top of the berm. So going around this direction and this direction, that would be the berm up here, and then one down here between the berm and the shed that goes this direction and this direction, and that's into these two catch basins or yard drains. So that's this exercise. So we'll go ahead and get started again. That's what we're basically doing. The side slopes of the swell, the maximum side slope 3:1. The minimum slope is 2%. So the swells going around the berm and between the shed and the berm, those will all be 2% or greater. So let's go ahead and get started. First thing we're going to do is, I showed you in that little picture here. Maybe I can set it here so you can look at it as we're doing it. Do this right there. You can't really. So let's go ahead and see if I can show this a different way. Do this. See that there? That. So we've got a person on this platform at 105.5 for their elevation, and the shed, top of the shed, the peak of the shed is 102.5. So let's subtract 102.5 from 105.5, and we know that our vertical drop from here to here is 3 feet. So with that, we need to put a berm right in the middle of that line, that view line right here. And in the book, they'll tell you to do a cross section and figure this out. But what we can do quicker, you know that this drops 3 feet, and we're trying to find that elevation right in the middle of that slope. So if it's 3 feet and we're putting the berm right in the middle, it drops basically 1.5 feet to right here. So this point right here would be 105. You can either subtract 1.5 feet or you can add 1.5 feet to this elevation, and that gets you that total 3 feet of vertical drop. So that puts the elevation of your berm at 105. So it's 105.5, 105.5 minus 1.5, and that gives us a berm elevation of 104 feet. So right here, this is 104, but what we've got to do in the book, they say to add 2 to 6 inches to the top of your berm, and that's to create that visual block here. So if we went to just to 104, that's that elevation right there, a person could conceivably see over the top of it. So you add 6 inches, and that puts your elevation at 104.5. It also makes it easier to show the contours, because then with this you have elevation of 104 on this side and 104 on this side, and then it goes up to 104.5. So let's draw that. This is 104.5. 104.5. And we will draw, actually I'm going to draw that horizontal so it doesn't block the contours. This is 104.5. And then if you draw a line straight across, because we've got this entire line across has to be elevation 104.5. So you have 104.5 here as well as here, because we have to block basically the visual triangle from here to here. All that has to be blocked. So we have to build this top of this berm all the way across at 104.5. And doing that, we have a 3-to-1 maximum slope. So if this is 104.5 and we're going to go downhill because it's a berm, if it's 104.5, we've got to drop vertically to the nearest whole contour, which is 104. We got to drop half a foot. At 3-to-1, that would mean that your contour needs to be at least 1.5 feet off from this elevation right here of 104.5. So if you come off 1.5 feet each direction, and this is 1 inch equals 20. Come up basically like this. 1.5 feet on each side. 1.5. 1.5. And you draw the contour parallel on both sides. This and this, and then this is 104.5, so you still have to stay 1.5 feet away from that. So you just come around the end, staying at least 1.5 feet away from that spot elevation. That's the top of your berm. And now we know that we have a maximum of slope of 3-to-1, and this is contour 104. So we'll put it on the uphill side, 104. And then we start coming downhill, and we do another contour, 1 foot contour, so it's going to be 3 feet apart. So we'll just come 3. Let's do this. 3, 6, 9, 12. So same thing here, just a 3, 6, 9, 12. So I'll draw these contours this direction on each side. So we're just going downhill 1 foot at a time. And then we've got to do the same thing on the other side because it's going downhill. We're drawing this, basically we went down 3-to-1 this direction, we got to go downhill 3-to-1 this direction as well. So we'll do that right here. So there's 3, 6, 9, 12. 3, 6, 9, 12. Draw these contours in. In there. And then we have to keep that same 3 feet apart going around. So this is 104, 103, 102, 101, 100. And we've got to get clear down to, this is elevation of the shed here is 94.5, the bottom of the shed. So if this is 94.5, we've got to get down to close to 95. So we got to keep going 3, 6, 9, 12. That'll get us to 100, 99, 98, 97, 96, 95. We got to go clear down to, this is 94.5. We got to get clear down to that same elevation of about 90. This is 94.5. We got to get down to, let's see here, we'll go 104, 103, 102, 101, 100, and 3 more. That gets us to 99. So actually this is 104. This should actually be on the other side. It should be 100 on this side, or 99. This is 100. And these other contours, you always put the contour labels on the uphill side of the contours. So this would be actually this. So this should be, uphill side would be this direction. So it is 189, 100, 101, 102, and 103. Those contours. And let's wrap these contours around because we have to connect them on the sides and stay about 3 feet apart. So we'll draw this. I'm only going to do this side because the other side is exactly the same. But for timing, we'll just show it on this side, and then you guys can calculate the other side. It's just a mirror of this side. So we've gone down. Let's get this into 99. So 3. Go. And so actually let's go ahead and connect these just so you can see. We won't put the swell on the other side, but we'll go ahead and connect these so you can see the berm start to form here. You just want to keep them, and you can run out of room, so try and be as accurate as you can. So 99. So if this is 99 and we're contour 99 here, we don't have to go any further with this contour. We don't have to put 98 because we're already down below 98. But if we connect, we could do something like, let's do this. Connect these here. So this is 99 here and 99 here. So this is going to be right here. This is going down. Right here we're coming down. So we have 99 here and 99 here, let's say. And we're putting this, we're going to put this low point here, and it's going to be about 6 inches lower. So this will just go, this is 98.5. Now our minimum slope is 2%, so you could measure this distance here and calculate and keep that at exactly 2%. But if we go 98.5, I think that's close enough, and that gives us that swell. And it'll actually be a shallower slope. And then down on this other side, we have to do the same thing. We've got down to 100, 99. We've got to get to draw some more in here. 3, 6, 9. So this is contour. Let's draw this a little straighter here. So that's 98. '87, 86, 95. So there we'll just go 90, 97, 96, and then let's do one more 95. 3. Because this is 96 and it's going over 95, we have to keep going downhill until we meet grade, and in a little bit you'll see what we're doing here. So this is elevation 95, and now we'll go ahead and connect these. So 99, 98, 98, 99, so 99 here. So 98 is going to be the top of your swell. See, this is 98.5, the high point. So we got to find where 98, the next lowest contour, whole contour going down your swell. If this is 98.5 and we're going downhill in that swell, we're going to find where 98 is. But what we're going to do is we're just going to draw lightly a swell line in here just to kind of guide us. And it might change just a little. So, but that gets us, so I'm going from this high point. This is the high point of the swell. It's not the high point of the grade, it's the high point of the swell going this direction down to this catch basin or this yard drain. And then what we need to do is we also need to put another one right here. So if this is 95, this is 94.5. This has to be basically, we could do this as 94. If we measure, we don't want to go to 94 because then this contour has to, we don't want to have, we'll have a whole contour. So if we go, say 90, that's 3 feet, 3 feet. Let's do, this is 3 feet from here to here. Let's just do 2% back. So if we do 94, we're going to have to put a 94 in here because it's so close. 100, 104, 3, 2, 1, 0, 99, 98, 97, 96, 95, 94. We do contour 94 in here. So actually this will be, let's do this. So we've got this contour 95, we've gone low enough. That's 3 feet. So 3 feet and 2% is our minimum slope. So let's find our vertical, how much that drops. Vertical equals horizontal times slope. So 3 times 3 feet horizontally times our slope of 2% equals 3 times 0.02, 0.06, 0.06. So if we subtract 90, let's see, 3 times 0.02 equals 0.06, we got to subtract, so 94.5 is our elevation here, 94.5, and we've got to subtract this vertical, 0.06 equals, so 94.5 minus 0.06 equals 94.45. So this would be elevation 94.45 would be your high point of the swell. And let's go ahead and just call that 94.4. Just for ease, we can just, and that is still meets our criteria of a minimum slope 2%. So if we put that, it makes it even gentler. So we'll just go, actually 94.45. Let's just use it, 94.45. So that's 2% going down. So now we've got to draw a swell this way to here. So we have a swell going this direction and this direction. And because our minimum slope, now this catches the water coming this direction, and you'll also have to put a swell going this direction. And same thing over here, you'll have to come around with a swell on this side down. But we're just going to do this side since it's the same on both. So if this is 94.5, we know we got to figure out what the elevation here. Let's use 2% as our minimum. So let's go from here to here at 2% minimum, and we need to find out, we know horizontally what we've got. If we scale it, we've got, looks like 44 or 39 feet from there to there. So 39 feet is our vertical from there to there. We don't know what our vertical, I mean that's our horizontal. We don't know what our vertical is, but we know our horizontal and we know our slope, which is, our slope is, they gave it to us 2%. So we're trying to figure out what our vertical drop is. So vertical equals horizontal times slope. We said our 39 feet, that's not your vertical, that's your horizontal. So 39 feet is from here to here, your horizontal distance. So 39 times 2%, that's right there, 2% times 0.02 equals 39 times 0.02, 0.78 equals 0.78. So this drops from here to here, 0.78 feet. So if we subtract, we'll take 94.45, and we're going to subtract this vertical distance. 0.78 equals 94.45 minus 0.78 equals 93.67. Write it right here, 93.67. 94.45 minus 0.78 equals 93.67. So that puts your rim elevation at 93.63. And we're doing 2%. And now we know what our rim elevation here is here. So now we can figure out what our horizontal, we know it's 2%. So this is 94.45. We got to drop to 94 at 2%. We don't know what the horizontal distance is, but horizontal we know equals vertical divided by slope. So the vertical is 0.45 because we're dropping from 94.45 to 94. So it's 0.45 divided by our slope, which is 0.02. 0.02 equals 0.45 divided by 0.02 equals 22.5. 22.5 feet. So we measure horizontally 22.5 feet, and that'll give us elevation 94. So let's do that. 22.5 puts us right here. So there's contour 94. And then that goes around here, but the rim elevation is 93.63, so we don't need to find a 93 between here because it's above 93, the elevation of the rim of this drain. So now that we've got that elevation and we've got this rim elevation, now we can figure out what slope we have here in this swell, because we know what our vertical distance is. It's 98.5 minus the rim elevation 93.63. So let's do 98.5, which is the high point of your swell, minus your rim elevation, which is where your drain is, minus 93.63 equals, what's that, 98.5 minus 93.63, 4.87. So you're 44.87. So 4.87 feet. That's your vertical drop from the high point of your swell down to your drain inlet. So that's our vertical drop, and then we got to measure our distance. We don't know what we got to figure out what the swell is, or the slope is. So we're going to measure this. You just do that by kind of rolling your scale, and we can get 30 feet, there's 40 feet, there's 50 feet, there's 80, it looks like it's about 82 feet. So the horizontal distance of our swell is horizontal equals 82 feet, and we're dropping 4.87. So what's the slope? Again, slope equals vertical divided by horizontal. So vertical is 4.87 divided by 82 feet equals 4.87 divided by 82 equals 5, so it's equals 0.059. So we can call that 6%. Let's round up to the nearest hundredth. So this well here is 6%. We've got 98.5, so now we've got to draw in our spot elevations for the whole contours along this swell line. With 98.5, we're going to drop half a foot. And so what we're going to do is, again, we're going to figure out horizontal. Write that horizontal equals vertical divided by slope. Our vertical, we're going to drop a half a foot to get to 98 from 98.5. So half a foot. We're going to divide that by our slope, which we calculated as 6%, 0.06, and that equals 0.5 divided by 0.06, 8.33 feet. So we just measure, this is 8.33 feet. That gets us right about here. So there's contour 98. And now we're going to drop a foot the rest of the way. So we got to go to 98, we got to go to 97, 96, 95, 94, and then we don't have to drop to 93 because the rim elevation is at 93.63. So we've got to do, now instead of 0.5, it's 1 foot divided by 0.06, and that equals, lost my lead here, equals, so 1 divided by 0.06, 16.66, so we'll just measure 16.7, about right there. So that's 98 here, this is 97, and we go another 16.7 feet. Oops. So 16.7 puts us right about there. So that's 96. 16.7 puts us right about there. Another 16.7. 16.7 puts us right about there. So there's 95 and 94. So now we've got to connect these contours. So this is 98. We have 98 clear up here. So we've got to stay 3 feet apart, come all the way down and around, tie into that. So there's 98, 97's here, and I've got to be 3 feet away because this is 98. So I've got to come 3 feet over, which I'm just about right there. If I come right like this, that's about 3 feet. Tie into there, and then 95 has to come around, or 96, this is 95, it has to come around, tie in here, and then 94, it hits right here and here, so we have to just connect these like that, and then we've got to come, if this is 93.63, if you come, that's a little less than half a foot from 94. So if we stay a foot and a half away from here, because we've got that 3-to-1 restriction, we'll be fine. So if we go, even if you went 3 feet away, it'd still be fine, about a foot and a half would be. So if we go around like that, so this is 93.63, we got to get to 94. If we're, for every foot, we have to stay at least 3 feet apart. So I'm just under 3 feet. I'm about 2 feet, so I'm fine there. So this, now we've got to tie in our swell. Here's 95, so we've got to tie back in to 95. 96, we've got to tie back into 96. 97, let's tie back in. And we're keeping, this is right here, 3:1 max. And then 98 comes clear down like that and ties back in. So there's the center line of your swell, so you can draw this center line right like this. The problem for the homework is at a little bit larger scale, so you'll have more room than this to draw, but 6%, that's our swell. So now we've got our swell, we tied back into our contours. This here is 94. So if this is 94, we could come up to 94.5. We just need to bring this. You could actually, instead of doing that, you don't even need to tie back in because there's 94. 94 is right here. So if we just tie into that, like that. Well, let me get that. That's right. 94. And then you need to kind of bring 94 back. That, because 94, you'd have 94.5 going right through here like this. Alright, so hopefully that makes sense. This side over here, you do it the exact same way. You draw your swell and then measure the horizontal distance, calculate your slope, and then locate your contours along that swell heading into your drainage or your catch basin. That's all there is to it.